Hello and welcome. Let's solve today top K frequent words. And let's get started. So, yep. Given an array of strings, words, and an integer k, return the k most frequent strings. Excuse me. So, return the answer sorted by the frequency from highest to lowest. Sort the words with the same frequency by their lexicographical order. So we are given words, string of words in the array. So I love lead code, I love coding. And the output is I and love. Explanation is I and love are two most frequent words. Note that I comes before love due to a lower alphabetical order. Is that because we are looking that I, like in alphabetic order, comes before L? That's what I assume, right? So, yep.
It's
And
also lexicographical order. So if you have two words that start with the same letter, you have to like move on to the next letter. Yeah.
look to the next one, right?
Yeah.
Yeah, that's what I wanted to ask. So, say we have like three words, right? And they all occur once, so we can return all of them, right? I assume like um what they mean by frequent. Like if there's only say if there's only one word in words array, can we still return that word, right? So it can be one word, and we're given the length of each word in the words array, and it says it consists of only lowercase English letters, which is helpful, and k is in range 1, the number of unique words. I think here we got it. Yeah, here we see that, right? So we are asked return an integer k, return the k's most frequent strings. So I think given array, I'm not gonna write it down, just gonna say return k frequent words, right? Yeah, if there's only one, this means there's only one unique word and just return that, right? And we also need to pay attention the way they are returned, right? So there is order in with order, and we have the order constraints right here. So I'm not gonna bother writing it down. In the matching phase, I wanted to see what kind of techniques or things I can use while solving this question. So what comes to our mind with the when we think about frequency, right? I think about dictionaries because they help us um, sort of count the number of occurrences of something. So I'm thinking of having a dictionary. Let's write it down, even if might end up not using it or using it. So I'm thinking of using dictionary and say we will start iterating through the given words array, right? And start counting how many times certain things occur. So we say, okay, I um, occurs twice, love occurs twice, lead code once, coding once, right? And then what we can do is that we want to return um, those two occurring those two occurring characters or words in their respective order. But I assume this question is kind of hinting towards using heaps, right? But I don't know how to use heap. So I think we can do with dictionaries, but I feel like this is more of a heap question.
You explain why you were saying heaps.
Yes, because we want to have, well, like I remember there was solving some question, some sort of a question like this, and this would give us like access. So the access would be constant, and adding and deleting from the heap would be constant, right? Oh, adding and removing from the heap is also constant. No, wait,
No. Adding and deleting from constant, I believe, is big O over log n.
because it's stored in like a tree-like structure, right?
It's a binary tree.
Yes. So I want to use heaps, but I don't remember how they are used on top of my head.
So, okay, so then let's not go with that. If you're not sure, you don't have to mention things if you're not sure of how to use them. So
Yeah,
we can go with dictionaries if you'd like.
yes. Um, so once we get the count, we want to, oh wait, so same thing with the dictionary. The only reason I think we want to use I wanted to use he because there's idea of accessing the most frequent elements in their order, in some sort of order, uh, which I don't remember how.
Do you want to dive into it now, or do you want to try and solve a different way and then afterwards try and figure out uh, a, a more optimal way?
Yes, I think I'm gonna go with something that I can do and then build on top with heaps, right? So, uh, so what I was saying is iterate through the words in uh, through each word in words, right? And then have our dictionary, which I'm gonna issue as an empty dictionary. Then say if word is, I can just say the word is going to be equal to um, d dot get the word, or let's get 0 instead. This is Python. I'm doing it with the help of Python, where I'm accessing, even if it's not there, I'm just getting the word if it's there. If not, I'm getting 0 and adding 1 to it, right? And then this is gonna help us count the number of occurrences of each word in the words array. So here, get occurrence, I mean frequency, right? Each word. So after that, what we want to do, um, we want to have some sort of way to access the dictionary. And so in the dictionary, the only problem is that if I'm getting the maximum, so how do I even get the maximum uh, from the what if I use set, and after I use set, I sort each tuple in the set based on the second based on the second value, which will be the frequency of each word. But one thing I see here is that I lose a track of this lexicographical order, right? So either way, I can make my way through this and uh, get get the case most frequent strings, but I don't know how to proceed with the way to display them. So I think I'm gonna stop here and probably go and learn how to do it with heat.
Okay.
And next time, I think I should take this seriously and do more code pass warm-ups.
Okay.
Yeah. I mean, can you walk us through this solution if you already solved this question or
Cool. Well, let me ask you a question before we log off. So, uh, you understand the general purpose of heaps, right?
no? I don't remember exactly.
Oh, have you heard of the term min heap, max heap?
Yes, but I don't remember how they work.
So, yeah, so the min heap stores smallest values as a parent, and as you trickle down, you get larger values. Max heap, the max value is stored at the top. As you go down, you get smaller values. So the idea behind the heap solution is to keep the most frequent elements at the top of your heap, right? And then once you pop from a heap, then the next element that goes to the top is the next largest element. And then you pop again, and then the next largest element. So you pop k times to find the k number of uh, most frequent strings.
All right. So as we discussed earlier, we said the heap is like a tree structure, right? So if the maximum, let's say if it's a max heap, as in our case, how we are the following nodes are structured. So we have the smaller ones from that one to the left and larger ones on the right, or how would that work in our
Yeah,
case?
so the top would, so yeah, so in our case, the biggest number, say, is 10.
Mm-hmm.
The left would be like, say, 4.
Mm-hmm.
To the right would be 8.
And it's like at each level, the root is gonna be the maximum,
Yeah.
and left is gonna be smaller, and right is gonna be bigger, but still smaller than the root.
Yeah.
Um, in the case of min-hib, it's gonna be the minimum at the root, and the smaller from that root to the left, and bigger, right? I assume bigger from that root.
Well, remember, min heap, it'll be the root node will be the smallest element
Oh,
in the tree.
mm-hmm,
So to the left will still be bigger, but to the left, relative to the right child, will be smaller.
mm-hmm.
Okay,
Okay.
1, 3, 5.
Okay, 135. That makes sense. So, yeah. So if you can walk through me, I would like code it up.
Well, I think the code is uh it's a little weird because you have to use the Python uh like built-in heap
Built-in
function.
heap function. Yeah.
Yeah, which is very tricky. And also the built-in heap function can only do a min heap. So there's like a trick where you have to make all your numbers negative so that the biggest numbers become the smallest numbers because you set them to a negative. And so now that they're the smallest, they go to the top. So So like if you had the frequencies of 2, 1, 0,
Mm-hmm.
or two, if you had the frequencies 3, 2, 1, a min heap would put the one at the top. So what we have to do is, because we're trying to actually get the maximum number of things, we
Mm-hmm.
have to change all of them to negative. So -3, -2, -1. And then the -3 goes to the top of the heap.
Why can't we just use the maximum heap, right? Max heap.
Yeah, the Python built-in function doesn't have it, it's always a min heap. So
Okay,
we have to invert all the numbers.
right.
But
Can you
I
draw?
can show you the solution.
No, I want to code it up and finish, and then
Okay.
if it's okay.
Yeah, yeah, that's fine.
And I assume once we put all the occurrences to the heap, we can start popping while k, right?
Yeah, exactly.
Yep. So let's get it. Did you pasted it in the chat?
I didn't post the solution.
What?
I didn't post the solution.
No, the heap thing.
Oh, you want me to put
Yeah, because
the
I
heap?
built-in thing, built in for Python.
Okay, so what do you want to do with it though? You have to tell me what you want to do with it before I give it to you.
So I want to put the occurrences in the word itself to the heap as in the order you said, like by negating the. So I want to have my dictionary, right? And for each word and in the count in the dictionary, I want to put it into the heap and then start popping from the heap while k.
Okay, so I will give you the function for that, but I will warn you. So what I will say is this function heapify will only work on an array. So
Mhm.
that's where your one caveat, you have to figure out how you're gonna do that.
So heapify. So only works in an array, right?
It can only heapify an array.
Okay. Then can we just make another array? Oh, wait. Can we? So I'll get it here. Why I cannot? So heap q is dot heapify, right?
Yes.
So I need an array, which is words array. And so what this thing is gonna give me then?
It's just gonna take whatever array you put into it and it's gonna heapify it, which means now that array will have the properties of a heap tree. Like you know how we can express a binary tree in like say uh in order and
Mm-hmm.
in order list or whatnot. In this case, your word array would be expressing your heap tree in an array format. It won't be in like in order or pre-order traversal. It has its own form, but it still just makes your array a heap.
That's
So, I mean, at that point, once it's a heap, then you just access the properties of a heap. So you can pop, you can insert, you can delete, and all of that cool stuff.
I think there was a way to like call heap q in the Python and have a heap and start putting it. I think there's a way to do it. I assume that you can, so you can append to the heap, right? Or add. Is it add?
Yeah, you can add it, but if you add each one manually, it's the same thing as just heapifying an existing array.
But I don't have an array. I have key and value pair, right?
Yeah. So that's for you to figure out how you want to. get to that point. Because if you want to heapify, you need to have an array. So what can you do with what you have?
I should turn this into an array somehow.
Somehow. Okay, that's a good start.
So I can say for key val in B and have a sort of an array, uh, words array, which is gonna be empty array at first and append to it uh, append to it and like an array this way, I assume, right? Somehow this way, yep.
Wait, why is it an array within an array?
Because
Why do you have two open brackets and two closed brackets?
I want to have these. Do you want me to store them as set or something?
Right now you have every time you append, you're going to append a list of lists every time.
Yes. Oh, wait. Yeah.
Okay, now you're appending a list every time.
Yes. That's what I want.
Okay, you can do that. Yeah. You can either do that. There's another thing you can do, but I mean, I
Like
think
I said, no?
it's not a set, it's a tuple.
Oh, yeah. Excuse my language.
Yeah.
So heapify is gonna figure out how to put it into the heap.
Yeah, you don't have to worry about it. It's big O of n complexity to
And
heapify.
what about this thing? Like, is it gonna have what's the deciding factor for it? Like, which ones it's gonna put into the top and which ones to the bottom?
That's a great question. So, um, what is currently doing, from what I understand, the first um, the first element in your, I guess the first element in your tuple is what's being sorted.
Okay, but I don't want that, right?
Yeah.
So I want it to be value in the key.
Okay.
What about this lexicographical order? Say we are asked to return in a lexicographical order, right?
So let's say the heap takes care of the ordering, right? But
Mm-hmm.
what is something you would think if say two values are the same?
Yes, that's what I mean, like two, right?
Yeah.
Two.
I believe the heap will look at the next value or the next option, which is the key. Now it'll probably sort by the key.
It's like doing magic, you know?
It is.
So I just say while k, my heap dot pop, right? And when we pop, we get um we get what we get a tuple, right?
So let me just quickly, because this is also a pop is doesn't quite work because heap has a special way of popping.
Oh, heap q dot heap pop, right? So I pop it like this, and I put my own array, right? Oh wait,
Mhm.
which array? My heap. Wait, what? Fourth count. So this should be my own heap, right?
No, heap Q is your function call. It's your keyword.
Mhm. So I'd say, and when I pop, I get tuple, right?
Yes.
How do I access the first one in the tuple? Like this?
Uh, yes, you should know this. This is Python stuff.
I think it's something like this. Come on.
I can't tell you because how do you access an index in Python? I can't, like, you can't be asking the interviewer, how do I access an index in Python?
That's why I'm
That
asking
just shows me you can't code.
myself. Dot append PR1. I don't think we did it correct. I mean, I don't think I.
You have a few